Good morning, good afternoon, good evening. Whenever you are watching this video, let us welcome you all to our channel Future Endeavors. Okay, so in the previous class we have started the chapter on heat. We have discussed about what is heat. We have given a brief review of what is temperature, and we have also discussed what is specific heat and how much heat can be contained in a body at a particular instant. Along with this, we have also today we will be going to discuss from the next part, that is we will talking about a bit more about the specific heat capacity and about latent heat. Okay, so without wasting much time, let us move on to our topic. So just having a brief recapitulation of the formula for the heat content in a body, we have noticed that we can write the heat content in a body as Q equals to mc delta T. What is the m? M is the mass of the body, C is the specific heat capacity, and delta T is the rise in temperature or fall in temperature. That is, we can say it is the change in temperature. Okay, so can we write specific heat capacity C as equals to Q by m into delta T? So if you consider that the mass, this is the, so C is the specific heat capacity. C is the specific heat capacity. Specific heat capacity. So if Q is the amount of heat, m denotes the mass of the body, and delta T the change in temperature, and if we consider that the mass of the body is say 1 kg and the change in temperature is say 1 Kelvin, then obviously specific heat capacity will be equal to the amount of heat content in the body in joule if we consider the SI units. So this is how we can define specific capacity. So specific heat capacity can be defined as the amount of heat content in a body of mass 1 kg when its temperature has been changed by say 1 Kelvin. In that case, the specific capacity can be considered to be the heat rise or heat gain or heat lost by the body at that particular instant. Okay, so I think the definition for specific heat capacity is clear to all of you. Okay, fine. So this is specific heat capacity. Now, if we consider the unit, what is the unit of specific capacity? If I consider the SI unit, okay, if I consider the SI unit, then SI unit will be SI unit of heat is joule, so it is joule. Then SI unit of mass is kg, so it's kg inverse, kg to the minus 1, and temperature, change in temperature, we can denote it Kelvin, Kelvin inverse. So joule, kg inverse, Kelvin inverse is the SI unit of specific heat capacity. There are other units also. We very often use units like joule, gram inverse, and degree centigrade inverse. We also use this kinds of units. But if I consider SI unit, then it is specifically joule, kg inverse, Kelvin inverse. Okay. So these are the specific heat capacity. Okay. Now, if I consider the specific capacity, so can I say that more the specific heat capacity of a particular material, more is the heat content of the body? Definitely yes. So think of the fact that water has a quite high specific capacity. Now there are certain natural consequences as a result of this water having a high specific capacity. Can you imagine some of those? Yes, I think the first thing that comes to your mind is that we use water as a cooling agent. Whenever there is a hot surface, we generally pour off water over that surface. What happens? The surface gets quickly cooled. Why? This is because for a certain amount of water, and say for a certain amount of any other liquid other than water, if you pour water over that surface, it will absorb more heat from that surface. Whereas consider any other liquid, it will absorb less amount of heat from the surface for the same quantity of the liquid and the water. So this is one of the consequences, this is one of the major applications that water has a high specific heat capacity, and we utilize this fact to use it as a cooling agent. Okay, so we will be discussing some more examples, but before that let me just briefly discuss the principle of calorimetry. Okay, so I think specific capacity is clear. If it is not clear, please pause the video, rewind a bit, and just recapitulate it once again. I think the concept will be clear to you. Now, consider. So we are now going to talk about principle of calorimetry. What is principle of calorimetry? Principle of calorimetry. So what is principle of calorimetry? See, principle of calorimetry, what it states that, see what happens when you take a hot body and a cold body, okay, and keep them in contact. What happens? You have seen often that your mother often cools the hot food by keeping it in a container and then keeping the container in cold water. So what she actually does, she keeps the hot food in contact with the cold water. After some time, you will notice that the hot food cools down a little bit and the water that was cool has become hot, isn't it? So this is actually the principle of calorimetry. It states that whenever two bodies having different heat content, that is, you can say also in this way that both are having different temperatures, when kept in contact, direct contact, the hotter body loses some heat, and where does this heat goes? The colder body absorbs that heat. So principle of calorimetry states that when two bodies having different temperatures are kept in contact, the hot body loses some heat and that same amount of heat is gained by the cold body. So the hotter body becomes less hotter, the colder body becomes less colder. Okay, so principle of calorimetry, just write it down, just let me write it down for you. It states that when two bodies having different temperatures are kept in contact, the hotter body loses heat and that heat is absorbed by the colder body, As a result, what happens? The hotter body becomes less hot and the colder body becomes less cold. So this is the principle of calorimetry. In ideal condition, that is theoretical condition, we can say that the heat lost by the hot body is exactly equal to the heat gained by the cold body. So we can write it like this, that heat lost by hot body is equal to heat gained by cold body. Okay, so this is the principle of calorimetry, and we have definitely some numerical problems related to this theorem. We will be doing these numericals in the next class, by the next class. Today just we will be discussing a theoretical portion. So heat lost by the hot body is equal to the heat gained by the cold body. So this is the principle of calorimetry. So I think the principle of calorimetry is clear to all of you. Okay. Now before discussing this principle, we are giving the example of water as a coolant. So what happens there? When you just pour the water over the hot surface, the water, which is having a lower temperature than the hotter surface, absorbs the heat from the surface and itself becomes hot